Maybe that's why he wants to be updated so often. Every time you open it, it wants a new update put in there, right? But then you don't know how long that update's going to take.
Yeah.
And then he's like, oh, well, I'll update it later. And then you forgot to do it later, and then it's there again every single time. All right, so this is a different project. Close that one. So last time we met, we solved homework 13, which was the sorting problem, right? Where we had to read in some, what did we do? We generated some random numbers, some number of random numbers, and then it took us to another screen that showed that list of random numbers unsorted. Then we clicked the sort button, and it sorted all those numbers by removing all of them from our current view group and then putting the new sorted version of it back in, right? Does that sound pretty accurate? And then at the same time, we introduced a kind of a more convenient way of sorting. So up to this point, whenever we needed to sort, we've always written our own little sorting algorithm. We either use insertion sort or merge sort or something like that. So if I'll do 50, so it scrolls to the next page. So here's our unsorted values here. Then I'll click sort. It removes all the, actually, no, we have them next to each other now, right? So we show the sorted and the unsorted. So this is the unsorted version. This is the sorted version. So these are two different, this is a horizontal linear layout with two vertical linear layouts inside of it, all sitting inside of a scroll view. It allows us to see all of it. So this just shows us the unsorted and the sorted. But in any case, up to this point, we've always written our own sorting algorithm to practice. So it might have been a merge sort or something like that. But now we kind of recognize that, you know what, sometimes I need to sort data. And when I need to sort data, it would be beneficial for me to have kind of a go-to quick use tool for doing that. And we did that this last time through something called arrays. So let's go back here. It's going to be in screen 2. So we said arrays.sort was our way of sorting. So this is on sort button clicked. We called the arrays class. So sort, what kind of animal is sort? Cat, dog, field, or method? Method. How do you know it's a method? Parentheses, like the parenthetical notation. That's got to make the final. All right, so we know this guy's a method because we have the parentheses here. Doesn't have to take any parameters, but it would be a method if it had that. Is it a class method or instance method? Class method. How do you know? All right, so we see it being called by something with a capital letter, probably the name of a class. Therefore, this guy, if he is a method, he must be a class method because we're calling him with the name of the class in which he was presumably defined. All right, so we have this arrays class that is kind of like a factory for us that knows how to do different things to arrays. So we say arrays dot, and we see that we have searches built in here. We can create a copy of an array. We can create a copy of a portion of the array. We can check to see if two arrays are equal to each other in terms of content. This is a nice one. We can fill an array up with some values. So let's say you wanted an array and make it filled with a bunch of zeros to begin with or something like that, just to have a starting point for it. Even though that is the default value that an integer array, for example, would be filled with, we don't want to rely on default values because that's something that could change. Potentially, it hasn't changed in years and years and years, but it could change. So maybe we use the fill function to go ahead and fill our array up with a bunch of numbers. Maybe the number is a 0, something like that. Or if it's a char array, we fill it up with a certain character. Maybe we filled up with a bunch of A's, something like that. So a nice convenient way of filling the array real quick without having to write like a for loop and filling it, something like that. Now, why is this fill function, which this guy is a class method. So I'll give you that as given information. Why does this guy take two parameters? Why does he take the array as well as what do we want to fill it with? Doesn't he already know about the array? So this is the difference between class methods and instance methods. An instance method is called using an instance of the class, but there's more to it than that. Because it's an instance method, it knows about the information contained in that particular instance of the class. So if we have a string and that string happens to be equal to elephant, the length instance method of string would know that elephant has 8 characters in it. Whereas if I had another string whose value was hello, the length instance method of that string would know that hello has 5 characters in it. So instance methods know about the data stored within the instance. Make sense? Class methods, they don't have that information because they're not owned by that string that held elephant or that string that held hello. Instead, they're owned by like the top tier thing, this building called arrays that you have to give it all the information you want it to work with. It doesn't know about what array you want to operate on. So we have to provide this guy with our array and then the value we want to fill that particular array with. Does that make sense? So this is a distinguishing difference between class methods and instance methods and why you might pick each. All right, we already have a way of defining arrays. We created an array, AR is equal to a new int array with 100 in it, 100 elements in it or something like that. We could already store the value of an array. What we really need the arrays class to do is to be kind of a factory that we can throw our array into, almost like a toaster, and have it process, do something. Okay? So that's why these guys to begin with are class methods. So we don't need to create instances of arrays. Instead, we just use the array's class name, and we give it the array we want it to operate on, or on which we want to operate. All right, so we can fill these guys up. This hash code thing has to do with, that's just like a security thing. A hash value is an unsigned, or it's a fixed size output for an arbitrary size input. It's used for encryption and things like that. The one we looked at here is sorting. So we see that we know how to sort a byte array. We can sort a char array. And notice that a couple of the versions of sorting here start with a from index and go to an end index. So we can sort only portions of an array if that was helpful to us for some reason. Okay, so we have lots of options for sorting. We can sort char arrays. We can sort double arrays. We can sort float arrays. Now, we can sort an object array. Now, we need to think about what does that mean for us to sort an object array. We can sort arrays of shorts. We can sort an array of a certain type using something of a comparator. All right, and we're going to come back to this in a little bit. So then we have a bunch of our toString stuff. Anything that shows up in red in here is something that's going away. So I would just pretend like it doesn't exist. They've replaced it with something else. All right, so that's all the stuff the arrays class can do. Now let's go and look at that arrays class, and let's specifically look at the idea of sorting objects. Okay, so let's go over to the documentation. I have it up here. All right, so this guy lives in java.lang. Oh, I thought it lived in java.lang. Must not. Maybe it's java.util. So here's our arrays class. Yep, it lives in java.util. So in order to use that guy, we would have needed to import java.util.arrays right here. in order to use that. Okay. So we've already seen this guy has a whole bunch of stuff for doing things to arrays. So let's go look at the static methods here, which notice not a whole lot changed because most of the methods in here, if not all of them, are static. And we're going to go down to sort. And when we're sorting our primitive types, that already kind of makes sense. We can use less than or greater than, those types of things to compare our various primitive types. But if we come here and we want to, let me see if I can get this to fit a little better. So this sorts the specified array of objects into ascending order according to the natural ordering of its elements. Well, what does that mean to be natural ordering? Okay, so we have this thing called comparable. And this is this is an interface. Now, what does it mean for something to be an interface? We've discussed that. What's an interface? It's a who? Not like a view. No, now you're thinking about our interface builder thing. We used interfaces when we had to pass one of our objects between two screens. We used the serializable interface. So what is an interface? What did serializable require us to do? Actually, serializable is a bit of a bad example because serializable actually did not require us to do anything. It just required us to advertise our object as having implemented the serializable interface. And then I think I probably showed you an alternative interface that, well, not an alternative, a different interface that solves a different problem called Runnable. I mentioned that most interfaces have able at the end of them, A-B-L-E. And the runnable interface is used in conjunction with threads, which we haven't written thread stuff yet, but effectively it says that anything that is runnable must implement a function public void run. So if you're going to advertise yourself as being an object that implements runnable, you then have now taken on the responsibility of writing a function within your object called public void run in order to adhere to the rules that implementing the runnable interface says you must have. So the comparable interface this guy says you must implement a compare to function. The compare to function must return an int, and it must take in an object of your same type. And it's going to return a 0 if they're the same, something smaller than 0 if the object that owns this compare to method, the calling object, is less than the object you passed it. So if the dude who owns this compare to method is less than O, it's going to return a value of negative something, less than 0. If the value that called it is greater than O, it's going to return a value of greater than 0. Okay, so the return value of this is an int. Now, let's say that we wrote our own object. We have an object in here that we've created in our current class. I don't remember. Yeah, we have a my object. All right, so this was the guy that we said implements serializable, right? So we said we have a my object. Now, Let's say I have, and when we create a my object, we create it with a string. Let me actually, just for the sake of argument here, let's just create a new, will be a little controversial per our thing we talked about at the beginning of class. So we're going to create a person object. Yeah, we'll add this to our code. So our person object, and actually, let me do a homework 14 template for this. Just start a new Android project. Make it an empty activity. All right, so I'll go ahead and create my person class in here. So I'm going to create a new Java class called person. All right, and let's say that we'll create kind of a simple person, but more complex than some of the objects we've made recently. So let's say a person has a name. Usually I have what, a first name, maybe an age, those three things. All right, so we're going to say that that is what makes people unique. A first name, a last name, an age. Oh, we'll say very controversial. We'll also say a string gender. All right, yeah, we'll get real controversial here. All right, so 4 different things that we're going to say identifies all persons. Okay, and we'll create our standard constructor for this guy. So here's our person constructor. This guy will take in a string first name, a string last name, an int age, and a string gender. All right, and we'll go ahead and set our local variables. So first name is equal to the first name that was passed in. This dot last name is equal to the last name that was passed in. This dot age is equal to the age that was passed in, and this dot gender is equal to the gender that was passed in. All right, so let's go ahead and create a couple of persons here. So we'll go into our main activity, and we'll just do this inside of, let's do it inside of our main activity. I'm going to go ahead, I'm going to create a person array called persons. And we're going to have a new person array. And we're going to put 4 persons in here, just because we don't want to have to create too many persons. All right. And we're going to say persons at bucket 0 is going to be equal to a new person. All right. Now the constructor for person that we just wrote, we have to pass in a first name, a last name, an age, and a gender. Okay. Those are the 4 pieces of information we need to give all persons. So we'll pass this one, Mike Littman, and it was just my 21st birthday. What? And we'll go male, and I'm going to steal all right. So now we'll create fictitious people. So let's go ahead and let's create. We're going to say Gail Littman. Man, how old's mom? I guess we could do scientific notation probably. All right, so let's say we'll be nice to her. So she is 40. All right, and she's female. And then we'll do dad. And we'll say he's 19. Oh, no, no. That's my brother. My brother is 19. So that's not my dad. That's my brother. Now we'll do dad. Like, that math doesn't work. All right, so we'll do dad here. And we'll say that he's 42. Okay. So we got the whole family. All right, we got 4 people. Now, I want to say arrays dot, well, let's go ahead and just give ourselves a quick way of printing out our array. So we'll create a little private void print array, and this guy will take in a person array as a parameter. And we'll just go ahead and we'll say for. Have we done a for each in here? For each loop? So here, let me show you. So one thing we could do is we can say for int I is equal to 0, I is less than p dot length, I plus plus, and then we can say, well, really, we need to have some way for a person to display themselves, right? Because if I just say system.out.println, p at bucket I, what's going to print here? Bunch of memory addresses, right? If I happen to call, if I say this dot print array and I pass it my persons, I'm passing it a 4 bucket array. It's going to go through here and print out 4 memory addresses, right? So let's just see that real quick. Person guy's complete for right now. So we'll go ahead and run this. All right, so let's look at our Android monitor. And here's our 4 memory addresses that printed out. All right, now we'd probably want it to print out kind of like, you know, Mike Littman, 21, male, you know, age, gender, something like that. So how do we make that work? How can we modify our code so that when we do a system.out.println, when I do this and pass in a person, that it will display something other than a memory address? Yeah, implement the toString method. So we go into the person class, and we'll go ahead and we're going to write a public string toString. All right, and this is something that we actually inherited from our parent. There's something invisible here. What's invisible up here? Extends object. So we extend other classes, we implement interfaces. It's the 2 things. All right, and we'll write some of our own models of this, but we extend other classes and we implement interfaces. All right, so up here, there's this invisible thing that says extends object. Object, something that's built into the language. It's the most generic object you can have, and it happens to come with a method called toString that displays the memory address of, that returns as a string the memory address of this object. So if I don't write my own version of that, I get the generic one, which then makes println work on objects by showing their memory address. Okay, so we're going to decide that that's not good enough for persons, so we're going to write our own version of toString. So we're going to do something called we're going to overload our inherited toString method. We're going to write our own. Okay? And what this guy is going to do is he's going to return a string. And that string is going to be this dot first name, followed by a space, followed by this dot last name, followed by a space age, colon, space, this dot age, plus space gender colon, let's hide this, plus this dot gender. Not the end of the world, but that was a little bit cryptic, right, to write all that. There is a version of this, I believe it lives in the string classes. It's string.format. String.format will do it, but so will printf. Just look at something here. Yeah, that's what we want. So the equivalent of this would be return string.format, and what we're going to pass this guy is a formatted string. So I want to say %s, %s, age colon, %i, it might be %d for decimal, space gender colon %s. And then what we do is we pass it the various values that we want to fill in. So %s is a placeholder for a string. %s is a placeholder for a string. %i is a placeholder for an integer. %s is a placeholder for a string. So I'm going to pass it this dot first name, this dot last name, this dot age, this dot gender. And I'll go ahead and comment this one out for right now. So this was a little bit easier to write, correct? We were able to kind of piece together, we were able to write kind of a sentence here, putting little placeholders in there to ultimately get us our pieces of information. All right, so let's run this real quick and make sure it's right and we don't need to change the I to a D. Didn't like something, so let's just try, before we do look at it anymore, let's try %D. So yeah, so I'll talk about why that's that way. But so notice now it says Mike Littman, age 21, gender male, Gail Littman, age 40, blah, blah, blah. All right, looks a lot nicer. So now what this actually comes from, this formatting, like we mentioned before, Java is a C-based language. So in the C programming language, we had a function, like instead of system.out.println, we had a function called printf. And printf used this formatting. So we would have done this exact same formatted string in C to allow us to kind of create something where and keep in mind back then it was far more common to write console applications where we had to write sentences like this. That makes sense? So I would say that today this is not real common, not because it's the wrong thing to use, but because most applications we're writing today, we would throw this in a label or something like that, right? But still, you might use format to put these pieces together. But in any case, here's an alternative to that to add to your toolbox. If you could always write it this way. This is not wrong. It's just tedious because you're just you're concatenating a whole bunch of strings together, right? So these two things are alternatives to each other. You pick the one you like the best. If you want to remember that there's an additional tool here that makes life a little bit easier, do that. If rather you just want to just work off the basics and just roll with the tediousness, go with that. It's fine. All right, so now we've taught persons how to display themselves or how to work with the println method so that when we output something, it doesn't just give us the memory address. We have this more local version of this. Now, what if we also wanted the memory address? What if I want this stuff printed out, but I also want the memory address? Who has my memory address? Yeah, my parent. So if I just wanted to just quickly do this, I'll just throw an extra %s on here. And then here I'll call super.toString. Call his toString, so my parent's toString method, which knows how to give me a memory address. So now I'm not replacing my parent, I'm augmenting the my parent's version of toString. And I'm going to go ahead and still use that value. So notice here we now have, here's our gender stuff, and then here's the whole big memory address thingy. Okay, so that's not all that helpful to us, so we'll go ahead and take that guy off of there. Just saw that that's a thing. All right, so now our persons can print themselves. Great. So next thing we're going to do is we're going to go into our main activity. And before our persons print themselves, we're going to say arrays.sort persons. Now, let's just see what this prints out first. Because what are we doing here? We are deciding who is the least worthy and who is the most worthy person in that list, right? So we're going to say bucket 0 should, well, it's usually we do ascending order, right? So bucket 3 should obviously be me. That's what it's supposed to say, yeah, okay. So let's run and just see what this does initially. All right, so it's screaming at us, and it's probably going to tell us that this guy doesn't know how to compare. Doesn't give us a very good error message, but it's definitely complaining about comparables in here. Here is our person. We don't need the extends object in there. That was just showing us something. But it's expecting this guy to have implemented comparable. So we need to ask ourselves, what makes one person better or worse than another? Well, how can we judge people? Maybe on age. Maybe we could say the youngest person should be sorted earliest and oldest is the in ascending order. So we can do this based on age. So let's go back to our, here's our comparable. Comparable says we need to implement this function, int compare to. I'm just going to copy that here. So up here in persons, we're going to say implements comparable for person. Oh, we're fine. It's just complaining we haven't implemented the class yet. That's fine. So we're implementing comparable person. And then down here, we're going to go ahead and we're going to write a compare to person. And we could probably call this P. Okay. Now notice this guy's happy again. Okay, he's happy again. And down here, we've written a compare to function that takes a person as a parameter, because that's what we're doing. We're comparable to other persons. Okay, that's what we're doing here. And we are now following the rules of that interface, and we're going to implement a compare to function. Now, what do you think this dude's complaining about right now? What would you predict the error message is? So one of our skills is being able to debug our code, right? In fact, it's probably one of our most important skills.
There's no return.
Yeah, this guy advertises that he returns an int, and I'm not returning anything in here. So if I hover over this, it's saying, well, actually, it's a different error right now. This needs to be public. Was it giving both errors before? It's interesting that it's happy with that for the moment. Showing red here, but I don't have a red here. Interesting. In any case, we've said this guy's going to return an int, and we have not returned anything. Oh, there's the little red down here. Missing return statement. So it did it down here, not up here. All right, so we've advertised we're going to return an int. Java requires us to return a value. All right, and we've decided that the way we're going to compare people initially, we'll obviously move towards sorting on gender, right? Just to stay controversial. Women are the best. So in any case, we're going to sort on age, and we'll have younger first, older last. Same as sorting on integers, except a person object is not a flat value. It's a compound value. It has 4 different pieces of information stored with that object, right? So we need to piece out the piece that we want to actually compare, even though it's an int and we already know how to compare integers. So we're going to ask the question. We're going to say, if this dot age is equal to p dot age, then we'll return a 0. I'm just going, I'm being verbose with this so we can see the individual pieces. We can come up with an algorithm that will actually be quicker. So if they're the same age, we're going to return a 0. 0 indicates for a comparable the same. Else if this dot age, the age of the calling person, the person who owns this compared to, is less than p dot age, then let's return a -1. It only has to be anything less than 0. Okay, -1 makes enough sense. Else, and if we want to be completely verbose, actually, we can't say an else if because it'll still complain. Let me just show you that. Else if this dot age is greater than p dot age, then we'll return a 1. Okay, now notice this guy down here is still complaining that we have a missing return statement. We happen to know that because this is an integer, these are the only possibilities, right? We have covered all of our bases. We are guaranteed to return a value from this compared to. But generically, Java isn't so sure because you're only actually returning a value if this is true. Otherwise, if this is true. Otherwise, if this is true. You don't have that catch-all else that says if all else fails, here's the else. Now, realistically, the makers of Java, because we happen to be looking at integers here, could have taken this a step further and decided this does cover all your bases. Integers are either equal to each other, less than, or greater than. So Java could be smart enough to make this call. But remember, they had to implement the method interface or the method feature of the Java language generically. And at this point, we're asking 3 different questions, and there's no guarantee from Java's generic point of view that any one of them will be true. That's why it's still complaining we don't have a return statement. So we'll just throw our else in here. If we're not equal to and we're not less than, we must be greater than, and we'll return a 1. Okay? So now we've implemented our compare to function, which our comparable person interface expected, which arrays.sort will use to compare one person to another person. So there's our 4 persons, with the smallest age being my brother, then me, then my mom, then my dad. Make sense? So now we can teach objects how to compare themselves to each other. Because otherwise, if we hadn't done that, since we're the ones who wrote the person object, would Java know how to compare them? I mean, first of all, what does it even mean to compare people? Maybe we want to compare them on age. But let's talk about, let's say we were writing an application for like records at a doctor's office, something like that. We might not really care what the age of our patients are. We might want to know the order by maybe the bill the most overdue, something like that. So we kind of know who to scream at first, who's latest on payments. We might want to have it ordered based on the amount that they owe. You know, if somebody owes 32 cents, maybe just write that off. You know, they wrote the check and didn't add the extra pennies on there. We're not going to chase them down for 32 cents. But if somebody owes 12 grand, maybe we chase them down for that. All right. So the way we compare people in those different applications might be different. So we have to teach our objects how to compare themselves to other objects. That makes sense? All right. Now, what if I wanted to compare on first names? So I want in my list here. So David would be first. My mom would be second. My dad would be third, and I would be last. If we were going on first names. Okay. So now those guys are strings. So I need to be able to compare strings. Well, strings have kind of another level in it. How do I ask that same question? Well, actually, before we even do that, can I write this more efficiently? How can I get effectively the same result of this without having 3 questions, a big if statement? Do it in one line. The Jeopardy music going. Will that do it? If my age is 15 and the other person's age is 15, 15 minus 15 is 0. If my age is 15 and the other person's age is 17, my age is less than theirs. 15 minus 17 is a negative value, less than 0. My age is 15, the other person's age is 13, my age is greater than theirs. 15 minus 13 is a positive number, greater than 0. So this would give us the same result, right? Effectively. The other one maybe looked a little cleaner. It's clear exactly what we were doing, but this one does give us the same functional answer. So, same result, same ages. But let's say now I want to do it on first names. So I'm no longer comparing integers. Now I'm comparing strings. And I want to know if the string, for example, Mike, should come before the string Dave. How do I ask that question? How do I compare one string to another string? If we're thinking about alphabetical, Dave should come before Mike. Did I do Dave or David? I did David. David should come before Mike alphabetically, right? But how do we ask that in Java? Can I just say if this dot first name is equal to this dot last name, return 0. Else if this dot first name is less than, I'm sorry, p dot first name. This dot last name is less than p dot. This dot first name is less than p dot first name. Then return a -1. Else return a 1. Can I do something like that? The big red underline probably gives us some sort of indication. So this guy says that we cannot apply the less than operator to strings. So I can't directly compare one string to another string using the less than operator. Well, let's go look at this string class. That guy lives in java.lang. Now, first of all, notice he has an implemented interface. So strings implement the comparable interface. What should I then find in the string class? When I scroll down here, there's one thing that we're guaranteed to have, since this guy implements comparable. Yeah, we're going to see a compare to function. So here's our compare to function that takes a string as a parameter and compares two strings, what's called lexigraphically. Now, lexigraphically is almost alphabetically, because the second one, compare to ignore case, actually would be alphabetically, because lexigraphically will look at Unicode values. So technically, a capital A and a lowercase a will be different, have different Unicode values, so it won't sort them alphabetically. Whichever one has the smaller Unicode value is the one that would fire. Okay, so we can use compare to directly if we want to sort just strings. Otherwise, so if I have an array of strings and I want to sort it, I could just call arrays.sort on strings, and it will sort them lexigraphically. I don't have to do anything special, because strings already implement the compare to function to compare themselves to other strings. But in this case, since I'm writing this for persons, that doesn't fly, because we still haven't explained how we're going to compare our persons. Now, we've said that why don't we compare them on first names? So if we're going to compare them on first names, we have to write the person version of compare to such that it compares the first names, which are strings, of the two persons. That activated OK Google, apparently. Thank you. All right, so.
No problem.
Perfect. At some point, I'm going to just say my mom's name. It's going to call her. And we would obviously have to just stay on the line and finish that phone call in class. It would be rude otherwise, right? You can't call your mom and hang up on her. All right, so compare to, I want this guy to compare the first name of the persons. What would I write here? It's one line. How do I compare strings? Well, I can compare strings to see if they're identical to each other using dot equals. But can't I directly call a strings compare to? Up to this point, using the arrays.sort, we've relied on the sort function to call this guy's compare to method. But we've called methods before that somebody else automatically calls. A couple minutes ago, he suggested we say super.toString to get the memory address of our parent, even though println automatically called our toString method. So now what we're doing here is we're going to say, look, you're calling compare to on person. That's on us. We invented the idea of a person. Well, not really, but the class person. All right, we implemented that guy. Therefore, it's on us to decide how to compare persons. But the way we've decided we're going to compare persons is by taking their first names and comparing them to each other. And it just so happens that the string class already knows how to compare itself to other strings. So I can just return this dot first name dot compare to p dot first name. Just compare the first names and pass the buck. Because this compare to, we already know it was written with the purpose of fulfilling the rules of comparable interface. Therefore, we know it's going to return a 0 if they're the same, a -1 if they're not the same, or if the first one lexigraphically comes before the other one, or something greater than 0 if lexigraphically it comes after. If we happen to want to do the ignore case one, we can say compare to ignore case p dot first name, and now we're full alphabetic, ignoring the case of the letters. So pick your poison. This compare to ignore case will not be called. I don't think it will get called by arrays. It's possible the array class has one of their functions for objects has a flag. Well, let's look real quick. Pretty sure it does not. So we would have to directly work with strings in order to compare them alphabetically, which isn't a big deal. I'm just seeing if there's a version of sort that allows us, that takes in a string specifically, and then does it allow us to say whether we wanted to sort it alphabetically or lexigraphically. This would be a workaround. So instead of saying that something implements and I wouldn't recommend this version, I'll just talk about it out loud. Instead of having our person class implement implement the comparable interface, which then forces us to write our own compare to method, we can instead use and this is an inline function. So we can sort this array, passing it this comparator thing. So this is a class that we would create that we teach how to compare two objects. All right, so comparator is another thing. It's this interface that we would say, here's my comparator. Go ahead and sort these guys by these rules. So comparators have a function called compare with inside them. Still returns the less than 0, the 0, or the greater than 0. Much more complicated to do that. The only reason why you might want to do something like that is if you were comparing objects I don't even know. I can't even come up with a great example of when you'd want to do that. Maybe if you had a generic way of comparing multiple different types. So let's say I had persons and cars and animals. I had 3 different objects. And let's just say I wanted to compare all of those based on their name. Let's just say each one of them had a variable called name. I could then write a single comparator that compares on a variable called name for all 3 of those. So instead of having to write compare to 3 times, I could write a comparator once and sort 3 objects that just happen to follow the same rules. I'm not sure that would ever be really, really, really worth it, but it's a thing. So in any case, it does not appear, the arrays class does not know how to directly sort strings themselves. So only if it knew how to directly sort strings might there be a option to say ignore case. Maybe a Boolean value would pass it for whether to ignore case or not ignore case. Instead, it just lumps strings into the collection of what's an object. So it says this can sort objects. Now, strings are already implementing comparable. So strings are ready to be sorted. We don't need to do anything special. But the arrays class hasn't defined 2 separate methods, one for implementing or one for sorting objects and another one for sorting strings. It hasn't done both. It just has a single method for anything that's an object. Make sense? All right. Not the end of the world for us. It's just how the tool works. All right. Therefore, for our person, if we wanted to specifically ignore case, we could use the compare to ignore case here. Otherwise, we would just use compare to. For us, it's not going to make any difference because we're doing it on first names. They should all have uppercase letters. But perhaps if we're relying on our end user to make sure they put somebody's name with an upper or lowercase letter, if somebody uses lowercase, that might sort them incorrectly, something like that. So let me actually show that. So we'll do a compare to here. And let's just run it once first. So I'm teaching it how to compare persons. And the way I'm comparing persons is I'm just returning whatever compare to returns on their first names. Okay? So this should lexicographically sort our persons on their first name. So there's Dave, Gail, Larry, Mike. All right. So now what I'm going to do is I'm going to go into our main activity and I'm going to make this 5 buckets. I'm going to steal this guy. And we're going to add a bucket 4. I'm going to lowercase my name. Oh, really bad example. Let's lowercase my brother's name. I didn't have to change the age, but this is Freudian. All right, so run this again. Oh. Don't need to be there. I just need to look at this. So notice that David comes first as well as last, because I happen to use a lowercase letter for his first name. That makes sense? Now, if I go into my persons and I instead say ignore case on that, now it'll do alphabetically. There's our 2 Davids next to each other. It treated these 2 guys as being equal to each other. And just because of the way the sort worked, the capital one came up first, probably because he was the first in the list. If we swapped the upper and lowercase d with each other, the lowercase one would have probably come up first. Does that make sense? All right, so you could use this approach with any kind of object that you might want to make. Kind of makes sense for us maybe to sort persons this way. Let's just look at a little bit of what I'm going to do here is I'm going to create a person class. He's not going to be comparable. I'll get rid of that. All right, so we're going to work with inheritance a little bit. So we're going to think about this doctor's office thing where we have patients, right? Now, is it true that all patients are persons? Well, I guess maybe if it's a vet, possibly not, but this kind of doctor, all his patients are persons, all right? Okay, all his patients are persons. That means they would all have first names, last names, ages, and genders, all right? Now, we're going to take it a step further because now you might have two different kinds of persons in the office, right? You might have employees and you might have patients. Now, a patient is probably going to have like a balance on their accounts and maybe a list of invoices or something like that, where an employee probably isn't going to have a balance. An employee might have like a pay scale or an hourly rate or something like that. So that's how they're differentiated in the office, right? They're both persons. They're both persons, but an employee has some different additional information than a patient would have. Make sense? All right, so what we're going to do is we're going to go ahead and we're going to create a second class here called patient. And what we're doing is we're showing, we're practicing inheritance. We're going to write our own inheritance here. So I'm going to say we're going to have a new Java class. This guy's going to be a patient. And we're going to say that a patient extends person. So it is a person. Okay? Right now it's complaining that we don't have a constructor for patient. We're about to put one in. So we're going to say public patient is going to take in a string first name. This will actually type easier here in a second. If I go back to patient here, I'm sorry, go back to person here. What does it mean to have these guys private? Private means it's only accessible where? In this class, in the class named person. I want to have access to them inside of a class named patient, which happens to extend person. So I need to loosen the reins a little bit and make these guys protected. So protected says that you have access to it within the class itself as well as children of the class. It actually means a little bit more than that, but let's leave it at that. All right, so now we've loosened the reins, made it available to our constructor down here. So now we can have first name. String, last name, int age, and then string gender, like that. Now we're also going to take in a double called balance, how much money they owe. We'll just differentiate them with one variable. Okay? Oh, I put a period there. There we go. Okay, and we're going to go ahead and we're going to say that, well, before anything else, we're going to say we're no longer, let's leave that for next class because we're running short in time. So we're going to say this is a patient. Now, all patients are persons. Therefore, we already have a constructor that knows how to set up first name, last name, age, and gender. So I can go ahead and call my parents' constructor, passing it first name, last name, age, and gender. So I'll let our parents' constructor do the initial work. This line must be the first line in this constructor. If we want our parents' constructor to do any work for us, it has to be the very first thing we do. Otherwise, we're on our own. Make sense? Now, we've decided that for a patient, we're also going to have a private double called balance. And we'll say this dot balance is equal to the balance that was passed in. Make sense? Okay. And then we'll go ahead and we're going to write our own public string toString. And this guy is going to get the string from our parents' toString and then tack onto it our balance. So we'll go ahead and return string.format %s space then balance colon %f should be for floats. And the first thing is going to be whatever our parents' toString returns, super.toString. That's what we want to put at the beginning of it, followed by our balance, which is this dot balance. All right, so this is how patients will display themselves. So now what I'll do here in main activity is I'm going to still have this persons array. But these are all going to be patients. Now we could certainly have put this inside of a patients array, but I'm kind of setting ourselves up for next time. All patients are persons. So if we have a container capable of holding a person, it can also hold a patient. And I just need to pass a balance to these guys. So let's do 125, 31, 13, 28, 0, 427, and 52,771 and 8 cents. Brother's a bit of a deadbeat. So, all right. So in any case, so those are going to be our patients. I'm going to not sort them yet. That's going to be your job for your homework. Now we're going to go ahead and print out our array. We're going to print out our array, which should print out these persons that happen to be patients. Make sense? All right, so for your homework, I'll put this up onto GitHub. Have it sort patients based on their balance. So take what we did today, and you can have it all output like this for right now. If you want to make an interface, you can, but you could use this just as your text-based output for now. So practice with the comparator and with get used to using inheritance. Make sense? All right, I will see everybody on Tuesday. I did put up the Bible homework. It's due midnight on Sunday. And I also put up next week's Bible homework already, and it's due midnight the following Sunday to give you a little more wiggle room with finals coming up. All right? So all your rest of your Bible homework is already up, and I gave you more time on this one because I was late in putting it up.